Council of Higher Secondary Education Manipur na lopa class 11 ki question naina si class 11 ki question ji common question oina council na siang bani aduga pekagi chi yengbodi masa gi school college na yengje gadawni common question ni yengsi 1 mark ki question. Write the dimensional formula of x in the given equation f equal to mx by t. So f equal to mx divided by t. So dimension of x, question is to find out the dimension of x. So dimension of f, dimension of t divided by dimension of m. So dimension of f is ml t minus 2, dimension of t divided by dimension of m. So cancel, so it becomes t l t minus 1. So next question is, give one example of inertial frame of reference. Inertial frame of reference is the frame of reference in which Newton's laws of motion holds good. So example is any frame of reference which is at rest or moving with uniform velocity are known as inertial frame of reference. Pulling is easier than pushing. Why? This question is 1 mark question ni adubu ay kitang elaborate oina take. So this is F, force F. A body of mass m is pulling along this with a force F, making an angle theta with the horizontal. Now, sigi F's we resolve into two parts, F sin theta vertically upward and F cos theta along this. So this F sin theta is along the direction of the normal reaction R, and weight mg is acting vertically downward. So we can write as F sin theta plus R is equal to mg. So from this we can write as R equal to mg minus F sin theta. So this equation 1. Now F cos theta is acting along this. Force of friction is acting along this. We can write also another equation, that is F cos theta equal to force of friction. So this equation 2. On the other hand, in the second figure, it is the case of pushing. Now the body of mass m is pushed with a force F. So now F we can denote it by this. So this F we can resolve into two components, one along this angle is theta. So F sin theta is acting vertically downward and F cos theta is acting along this, and normal reaction R is acting vertically upward. So we can write the equation R is equal to F sin theta plus mg. So this equation 3, and force of friction is acting along this. So the horizontal component F cos theta is equal to Fk. So it is same in the both cases. Now you see equation 3 and 1. So from equation 3 and 1 we know that the normal reaction in the case of pulling is smaller. So pulling is easier than pushing. Now next question is, give the condition for work to be positive. 1 mark question. Now we consider a body of mass m, a force F is acting along this, making an angle theta with the horizontal, and the body moves along this. Now, work done, from the definition of work done, is defined as force dot displacement. So, the magnitude of the force, magnitude of the displacement, cos of the angle between F and D. So, work is positive if theta is less than 90 degree, means when theta is equiangle. Next question is, what is meant by inertia of motion? Inertia of motion is the tendency of a body to remain in its state of uniform motion in a straight line. Inertia of motion, inertia of rest, inertia of direction henalei. Body amagi tendency to remain in its state of rest or state of motion is known as inertia. So in this case, the inertia of motion is the tendency of a body to remain in its state of uniform motion. Now, next question is, the moment of inertia of two rotating bodies A and B are IA, where IA is moment of inertia, and IB is moment of inertia of the body B, and their angular momenta are equal. Which one has greater kinetic? Sige answer di kitang ay sang elaborate oina dum take, although it carry 1 mark. The kinetic energy of a body having moment of inertia I and angular momentum L is kinetic energy T equal to half I omega square, where I is moment of inertia and omega is angular velocity. So this we can put as L square by 2I. Now, for body A, kinetic energy is LA square divided by 2IA. So this is equation 1. And for the body B, the kinetic energy is LB square by twice IB. So this equation 2. Now it is given that angular momentum means LA is equal to LB, and it is also given that moment of inertia of the body A is greater than moment of inertia of the body B. Now look at equation 1 and 2. Now divide equation 1 by 2. What do we get? LA square by 2IA divided by LB square by 2IB. So it is IB by IA. Since IA is greater than IB, so this is less than 1. Hence, kinetic energy of the body B is greater than kinetic energy of the body A. Now, next question is, when wax is rough on cloth becomes waterproof. Why? It is because of the surface tension. Kaigino ta ngasai gi wax si cloth rub taw matam sita kadawi water cannot stick because of the surface tension. Like that, koina car ama fazana wax tairaga samthong matam da nong taraga zu rainwater cannot stick. It is because of the surface tension. Draw the PV curve for isothermal and adiabatic process of an ideal gas. So now we draw along x-axis volume V and pressure P along y-axis. So this is adiabatic curve. This is isothermal curve. So this is compression. See, this is the case of the compression. The upper cup is the case of expansion. Now next question is, draw a graph showing the variation of amplitude with time for a damped oscillation. Damped oscillation adi kaino haita di akoina sigi pendulum mama mata mai vibrate to matamda magi se pendulum mama vibrate to matamda magi amplitude se some pixel lakta finally it comes to rest. Adu akoina damped oscillation mangonda ek toribo force to put damping force kawi. So now if we draw time along x-axis and amplitude along y-axis, the curve is like this. Curve is like this. So this is the variation of amplitude with time for a damped oscillation. What is meant by free oscillation? Free oscillation means if on displaced or disturbed from its position of equilibrium, it is left to oscillate itself without outside interference. Say simple pendulum am lai. Now simple pendulum si sida kitang displaced tore. Displaced torkanda thadok matamda kadawi it make a to and fro motion without outside interference. Such type of vibration is known as free oscillation or free vibration.